Test the conversion of the series and go from 1 to infinity of -1 to the n, the square root of n over n plus 4. This is an alternating series, so we will use the alternating series test. The terms a sub n's are -1 to the n, the square root of n over n plus 4, where b sub n, which are the positive terms only, the square root of n over n plus 4. There are two conditions that we need to check for the alternating series test for the series to converge, and that is 1. We need to check that the limits at n go to infinity of b sub n is 0. 2. We need to check that b sub n is greater than b sub n plus 1. This shows that the positive terms is decreasing. It is getting smaller. For the first condition, we simply take the limits at n go to infinity of the square root of n over n plus 4. This is a simple limit where we would simply divide by n to every single term, n being the highest degree in the denominator. This is the limits at n go to infinity of the square root of n over n is 1 over the square root of n in the numerator. N over n is 1 plus 4 over n. And as n go to infinity, we see that 4 over n go to 0 and 1 over the square root of n go to 0 as well. This is 0 over 1 or 0. So the first condition is satisfied. The second condition, we can directly show that the terms are decreasing, or we let f of x be the square root of x over x plus 4. We then differentiate f of x, the derivative of f of x at prime of x using the quotient rule. We square the denominator. The derivative of the numerator is 1 over 2 root x times the denominator x plus 4 minus, keep the numerator, and we multiply the derivative of the denominator, which is 1. This is 1 over 2 root x times x plus 4 over 2 root x minus root x over x plus 4 squared. In the numerator, x over the square root of x is the square root of x, plus 4 over 2 is 2 over root x minus root x, and the denominator is x plus 4 squared. 1/2 root x minus root x is negative 1/2 root x plus 2 over root x over the denominator. The denominator is positive, so we can just simply ignore it. The goal is to show that this derivative is negative so that the terms are decreasing. We would then rewrite this. The numerator has a common denominator of the square root of x, so we would multiply the square root of x over the square root of x. It also has the denominator 2, so we would multiply 2 over 2. Inside this parenthesis is negative 1 over 2 root x plus 2 over root x. This is now 2 times negative 1/2 is negative 1. Root x times root x is 1x. And 2 root x times 2 over root x is plus 4. Over 2 times the square root of x times x plus 4 squared. Remember that x is n, and n start with 1, so the denominator is always positive. The numerator for minus x is negative for x greater than 4. For the second condition, we need the term to be decreasing, but we don't need it to be decreasing starting at n equals 1. We just need it to be decreasing at some n, and we see that at n greater than 4, the term b sub n will be decreasing because the derivative is negative for n greater than 4, or specifically x greater than 4. This shows that the second condition is also satisfied, so we conclude that the given series is convergent by the alternating series test.